Lesson on trigonometry, and so we're going to be dealing with angles between 0 and 360. So the goal today is to make connections between angles of 0 and 360 and the primary trig ratios, and the angles where the ratios are the same. So we're going to be making a bunch of connections between uh, all the way from 0 to 360 of sine, cos, and tan. We're also going to be learning about secant, cosecant, cotangent, which are the reciprocal trig ratios. So we'll actually start out with is something called the unit circle. And so this is the unit circle. Um, so one thing we do in class is we actually have students measure the different coordinates. And so at a 15-degree angle, you can actually, like with a protractor, find out what that angle is and measure the xy coordinates. Now with this, because it is a scale of 0.2, we can kind of estimate what those values would be. But it's really powerful to actually go around the circle measuring the xy values between 0 and 1 and finding out what the x coordinates are and the y coordinates are. Because you start to notice that as soon as you get to 90 degrees, things start to repeat. And so, like if you had 15 degrees, let's say right around here, the x value could be like 0.96, and then the y value could be something just over 0.2. But over here, the x value is very similar, except it's negative and positive. And it's really helpful to kind of do that um, with a unit circle, because then you start to be able to make connections around the circle. So as you get 15 degrees and then to 90, and then every 15 degrees all the way to 360, you start making connections. And those connections that you make, you actually notice that, like the sine and cosine, the x is actually represents the cosine, and the y values represent the sine. So you start to like actually learn more about what sine and cosine are and why they are the way they are for angles bigger than 90 degrees. So we're gonna look through some questions here and some theory and some examples. So given a point on the terminal arm of radius r, so this is a circle. Any point you can form a circle with any point. We'll call that point x comma y, and so this is actually what we call the terminal arm. And so it's the arm that connects 0, 0 to the point. Um, we have this angle, which we call theta, and so we use the Greek letter for angles just to differentiate between angles and sides. The terminal arm, and then we actually have the, the x and y coordinates tell you that there's x distance and y distances that happen to make up those coordinates. They're kind of the components of the coordinate. So it's a horizontal distance and a vertical distance. The radius we can call r, and we actually know the ratios for using SOHCAHTOA. The primary trig ratios are sine theta is y over r, which is just opposite over hypotenuse. Cos theta is x over r, and tan theta is y over x. And these are actually seen in the unit circle because if the radius is r, sine theta is y, and cos theta is x. And it's true all the way around the triangle. You start to see that things are the same around the circle. The reciprocal trig ratios, by definition, are really if we divide it in an opposite order. So if you think about all the combination ways that you can divide the three sides, there's actually 6 different ways, not just 3. And so if you divide it in an opposite order, r divided by y instead of y over r, we call that cosecant. When you divide r by x, we call that secant. And when you divide x by y, we call that cotangent. Reciprocal trig ratios prove important later on in functions in calculus, because you can imagine that like something like 1 over sine, it actually is nicer to write as cosecant. And they also have their own properties that allow us to work higher level math with. So an example here, we're going to just plot the point -3 comma 4. And so we can see the terminal arm connecting the 0, 0 to that point. The angle that we're going to measure is this angle, that's the theta. To do that, like because theta, and if you go around the unit circle, you start to see this angle is very closely related to this angle, which we'll call beta. Beta is the related acute angle. It's very closely related to theta. Actually, the ratios are all the same. It's just the difference with theta is it can take on values that potentially are negative for the x's or the y's. And in this case, the x value is negative. We have this little right triangle so we can get components of the coordinate. The height is 4. The base is actually -3, and so that's going to be important when we summarize the ratios for theta. Beta will always be +3. It's an acute angle, but for theta, the -3 is what's the difference. And the r value is 5. You can probably get that pretty quick from Pythagorean theorem, but just showing Pythagorean theorem and seeing that, like, if you had the x value of negative, really just proves why r is always positive. X and y can be negative, but r will always be positive. So the primary trig ratios are really from beta, but using theta. The primary trig ratios on theta are sine theta is opposite over hypotenuse, so it's 4/5. It'll be the same. Cosine theta is -3/5. Tan is -4/3, opposite over adjacent. Cosecant's 5/4, just the reciprocal. Secant's -5/3, and cotan is -3/4. Using one of these, we can actually get beta. And so by getting beta, we just ignore the fact that there's negatives. So we probably want to use this one. This sine theta is 4/5, or you can use this one. But to find beta, we just do the sine inverse of 4/5. It'll work the same to do the cos inverse of 3/5 or the tan inverse of 4/3. But you want to ignore the negative sign because you do want an acute angle, 53 degrees. If you do the cosine or the cos inverse or the tan inverse of the negative, you will get something close to 53, and you might get something that tells you that the related acute angle is 53. So often you'll get like -53, or you get an obtuse angle, but it's the obtuse angle that's harder to tell where the acute angle is. Now we know beta, we can figure out theta, and so theta is just supplementary to that, 126.